So welcome to CTIA Supermobility 2015. My name is Andreas Roessler. I'm a technology manager with Rohde Schwarz, and we are exhibiting here at the 5G Innovation Lab. And as 5G is a big buzzword in the industry, we thought it's worthwhile to present what test and measurement solutions we can bring to the table in order to accelerate the 5G research that is currently going on worldwide. So there's a few corner points about 5G. First of all, moving up to millimeter wave frequencies to find more bandwidth, getting higher data rates. That's an aspect which we cover very well, because the two boxes that you can see here, which is the SMW vector signal generator and the FSW signal and spectrum analyzer, cover millimeter wave frequencies. The signal generator goes already up to 40 gigahertz, where we have potential candidates for 5G being 28 gigahertz or 39 gigahertz. And our analyzer, this one right here, goes up to 67 gigahertz. So it would even cover the V band. And we have a new model coming that supports 85 gigahertz, so all the way up to the E band, which also is currently researched by some industry key players. The other important fact is how we overcome some of the challenges that LTE as a waveform gives us. So we want to have, for instance, a more spectrum agility here. And what I did is I'm generating right now an LTE signal, as you can see here. You see the characteristic power spectrum, and as you can see, we have these roll-off factors, roll-off here on the left and right hand side, and that requires a guard band to surrounding systems so that we don't have an impact. So is there anything that we can do about it? And yes, there is. What Rohde Schwarz did is basically on a single generator, we implemented 5G waveform candidates. So if I just open up the personality, you will see that Rohde Schwarz has the capabilities to generate these newly discussed waveforms like UFMC, that stands for Universal Filtered Multicarrier. So if I just select UFMC for simplicity here and activate that, you will see that my spectrum goes away and the waveform is being calculated, of course. So it takes a while. And there's the spectrum again. So if you noticed, this roll-off is pretty much gone, right? How could that be? UFMC is still an OFDM-based modulation scheme, like LTE is, but the difference is basically as usual in the details. So what UFMC does is basically doing a different pulse shaping to the individual subcarriers. You can even do it down to the subcarrier level, or you create subbands and filter that, and all this gives you the capabilities to have a more spectrum agile waveform than LTE. That is currently being researched by many companies worldwide and might be a candidate for 5G as a waveform. Thank you so much.
Hi, I'm Greg Bonaguide with Rohde Schwarz. I'm a product line engineer, and we're here at the CTIA show in 2015 at the 5G lab. And what we're showing here is our vector network analyzer solution for 5G. Now with 5G, we're going to be up into the millimeter wave frequencies. So the idea here is a customer that has one of our existing vector network analyzers for work up to 6 gigahertz can use their existing analyzer, in this case a ZVA24 that covers 10 megahertz to 24 gigahertz, and they can simply add some harmonic converters that will allow operation up in the typical E-band frequencies of 60 to 90 gigahertz or so for doing component measurements up at those frequencies. So what we're showing here today is we've got a pair of these harmonic converters. They are actually operating in the 75 to 110 gigahertz range, and we're measuring a simple band stop filter. The band stop filter is tuned for a center frequency of about 85 gigahertz or so. And the beauty of this setup is that you can operate it just as you would a low band analyzer. It makes it very easy for the customer. We also have some solutions with our spectrum analyzers. Our latest version of the spectrum analyzers, the FSW, covers up to 85 gigahertz. And we also have instantaneous demodulation bandwidths on the FSW of up to 2 gigahertz. So that too is a product that's going to be E-band ready for when the industry needs test and measurement capabilities up there.